Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. We've talked a few times over the past few months about memory safety and how some languages like Swift, Java, Python, Go, and Rust are memory safe, while other languages like C and C++ are not. Well, apparently, C++ got sick and tired of being called a non-memory safe language, so it decided that it is going to fix that for real this time, though, because it's tried numerous times in the past to no avail, but this time it's for real. That it plans to change the fact that it is a non-memory safe language and make it memory safe. So we will break that down in this episode, but before we get into that, let's start off with our trivia question for the week. So, introduced in 1985, what line of Commodore personal computers has a name that means friend in English? So what is the line of Commodore personal computers that has a name that means friend in English? And that is your trivia question for the week. Now, before we get into our cybersecurity tip, I did want to touch on some news that has been going on with YubiKey. Now, if you're not familiar with what YubiKey is essentially a hardware device that can act as a multi-factor for your multi-factor authentication. Now, we've talked ad nauseum about the importance of multi-factor authentication and why you should have it set up on all your accounts. Because at the core of multi-factor authentication, of course, you have like the three main pillars, right? The something you know, which is generally your password, something you have, which is some kind of, maybe it's your phone that you're getting an SMS message, not very secure, or you have an authenticator app like Google, Microsoft, Duo, or something like that, or you have a hardware device like a YubiKey or a smart card or some other physical device that will provide a second authentication factor that you would need to have. And then, of course, the third one is something you are. So this is like your biometric data. So things like, a retinal scan, a face scan, fingerprint scan, that kind of a thing. So YubiKey is a pretty widely used multi-factor option for like a physical device for your multi-factor. So it's widely used, but the issue that we're bringing up here is it contains a flaw in the current YubiKey 5 that allows an attacker to essentially clone the YubiKey and be able to have access to your multi-factor thing, assuming they can get temporary access to your YubiKey. So this is essentially a side channel attack of sorts that gets performed on the microcontroller inside the YubiKey itself. I don't want to get like super technical into the weeds, but essentially if an attacker was able to get access to your YubiKey, they could, do some fiddling with it, and they'd have to essentially take it apart, so it'd be noticeable that it was done, but it is something that could happen. There's some good news about this, though, is devices that are running firmware version 5.7 or I guess later are vulnerable, but if you have a newer YubiKey than that, you're fine. Kind of the issue here is YubiKey's firmware isn't updatable, so you can't update it to the latest version. But if you bought a YubiKey like within like the past month or so, I think you're probably fine. But specifically the flaw here There's something with like the elliptic curve digital signature algorithm. The execution time differences can be leaked, and thus the private key can be cloned, and that's kind of essentially how it works. But as far as like what you need to actually perform the attack, like I mentioned, one, you need physical access to the key itself in order to clone it. And then the estimate is around like $11,000 worth of specialized equipment in order, and the not to mention the expertise in order to do this. So based on the Ars Technica article, which I'll have linked below, it's basically like a state-sponsored, scale level of attack. But essentially, the attack method is the threat actor will steal your login and password, and then they need to gain temporary access to your YubiKey in order to measure the various electromagnetic radiation during the authentication. And then by doing that, they can perform side channel analysis in order to extract that elliptic curve digital signature algorithm and clone the YubiKey. So definitely not something your average Joe is really going to be able to do. So in all honesty, it's probably not something you need to worry about too much because of, what all needs to go in order to perform this exploit, but it's definitely something to keep in mind if you have had a YubiKey for a while. Your YubiKey, there's a good chance it's vulnerable to this, but again, as long as you keep it on you, you're probably fine. Like the only issue you might run into is if you notice you come back to your YubiKey and it's damaged in some sort of way, or you lose it for some reason, then you might have some reason to be concerned. But otherwise, there's really not a whole lot you need to be worried about. So kind of like I said, to kind of summarize here, newer versions of the YubiKey are unaffected by this and are secure, at least as far as we know. And the current YubiKeys cannot be patched. So, but like I said, as long as you keep it on you, you don't really have too much to worry about. Because, like I said, the attacker would need physical access to the key itself. So it's not like, they can just walk past you with some like RFID scanner to clone it like they do, some other kinds of various cards and RFID authentication methods. So not like a ton to be worried about, but I just thought it was interesting to bring up. So with that, let's get into this week's cybersecurity tip. Now, this week's cybersecurity tip is similar to one that we talked about maybe a month or so ago, maybe a little longer than that. And this one is to lock all of your devices when you aren't using them or shut them down. Because like we talked about in that previous cybersecurity tip that I was alluding to about making sure that your encryption is actually working for you. In essence, if you have encryption enabled on your laptop or whatever, it doesn't really do you any good if the laptop is powered on, right? Because at that point, and if the laptop is powered on and you're logged into the operating system and you did that first boot process, the drive is decrypted. So your encryption only really works if it's active, right? So in a similar vein, locking your devices and password protections on your accounts for your devices only works if your devices are actually locked, right? So if someone were to come up to your desk while your computer was unlocked, they could basically have free reign to look at whatever they wanted to on there. But if they came up to your computer while it was locked, well, then they'd have to either know your password or find some other way to get around it, and it's not as simple as I just get to your computer and I can look whatever you're doing. So whenever you have to get up to like use the bathroom, grab a snack or something to drink or something like that, you should always be locking your devices and never leave your devices unlocked and unattended. because unlocked devices are a gold mine for would-be thieves. I mean, we just imagine the gold mine that your device is if you have it unencrypted and you have a bunch of, personal information on there. If you sell it on eBay or something and a threat actor gets a hold of it, they can essentially pull all your personal data off there and, steal your identity. Similar thing, like especially if you're in a public place, you definitely want to be making sure that if for whatever reason you get up from your computer or whatever and go, grab a snack, grab a drink, whatever, make sure you lock your computer, because especially if you're in a public place, someone could easily just walk by and, do stuff on your computer. Now, we've talked about this previously, but this is essentially how some of the big dark web kingpins got busted, because they left their computers unlocked and the feds managed to swoop in and snag it while it was still unlocked. And some of these raids happened while they were actually at home, so maybe it's another point that even if you're at home and you get up to go away from your computer, you should be locking it anyway. Now, of course, I should note the distinction between locking your computer versus re-encrypting it. So if you're just, booted up and you're, logged into the desktop, for instance, and you lock it, that's essentially just locking your account, so you have to re-enter your password in order to log back in. But the drive itself doesn't re-encrypt itself. I mean, you might be able to configure it to do that, but by default, once you do that initial boot up process, the drive's decrypted, right? Like you'd have to do some really funky steps in order to get it to encrypt itself, when you lock the computer, because the reason why the drive stays unlocked is because if every time, you put the computer to sleep or, lock the screen or whatever, you'd have to essentially re-decrypt everything in order to be able to use your computer again. So there is a distinction between locking your computer and encrypting, your drive. But even still, having, that extra layer of defense being the password to actually log into your account, or if you're using some other kind of authentication method, whether it's like a smart card or, a YubiKey or something else, or biometrics, having that additional layer to prevent someone from that would-be attacker that just wants, an easy target, it's definitely good to do. But even if you're just out in public, personally, like especially with like phones and stuff, I would encourage people not to be on their devices in public aside from depending on where you are, it could be seen as rude. But I'm sure most of you have seen the videos of someone that's just kind of out in public, just kind of chilling on their phone, and then some thief, happens to, come up behind them or something and just grab the phone out of their hands and run off. Well, if they were on their phone, I would assume it was unlocked, and that point, when the thief runs off with it, the phone's unlocked, so now they have access to everything on the phone, which I think, as you can kind of gather, is not a very good thing to happen. So like the previous cybersecurity tip, your security is only as strong as its weakest link. So, a full disk encryption is useless if your computer's powered on, and similarly, an account password is useless if you're already logged in sitting at the desktop. So that is your cybersecurity tip for the week. Make sure to always lock your devices when you are not using them, or you could just shut them down too. And that is your cybersecurity tip for the week. Now, before we get into all of that drama with C++, let's get into what nerdy stuff have I been up to this week. So that video game I've been working on, it's been a while, hasn't it? Well, I did do a little bit of work on it, not necessarily a whole lot of coding, because I was doing other things with it, but I decided I wanted to try to get the bag/inventory menu kind of set up. And of course, for part of that, I had to do some graphical work to get the assets prepped in order to be able to actually write the code to implement it. So I did write like a tiny bit of code just for like some of the dimensions for some of the like the tile sets and stuff. But as far as like actually implementation goes, didn't really get a whole lot of that done. But I did pretty much get like the sprite sheet done for it. So now it's at this point it's pretty much just a matter of doing the implementation and actually writing the code to display everything. But aside from that, I did a what I'm calling a supercut, if you will. So I'm not sure if you guys have heard of either supercuts or compilations, or where essentially someone makes a video compiling all instances of something happening, whether that's in a franchise or whatever. So things like every Star Wars lightsaber battle from all the movies, or another classic one is every time Owen Wilson says "wow" in one of the movies that he's in, things like that. So for my own personal entertainment, I wanted to make a similar of compilation of sorts. Now, obviously, looking for a phrase like Owen Wilson saying "wow" in all of his movies is gonna be a little tricky to do unless you want to watch every single movie he's ever been in and then identify every place where he says wow and make those cuts. That's obviously way too much work. So obviously combing through, potentially hundreds of hours worth of footage was not going to happen. So instead, I let Python do the work. So thankfully, all the source material I was trying to use was on YouTube. So I was able to dynamically pull all the video IDs and then run those video IDs through a Python YouTube API wrapper library of sorts to essentially download the auto-generated transcripts that YouTube makes for all the videos that's on its platform. And then based on that, download the transcript and then just use Python to essentially search the transcript for instances of, the words or whatever that I was trying to look for. And then based on that, I was able to extract not only the words, but also the timestamps when those words or phrases were said and, essentially output that with the video links. So every instance that I wanted to search for, I found it and the corresponding timestamps, so I could easily just download those videos and then cut to those portions to extract them and then put them all together in a compilation. So essentially it saved me literally like hundreds of hours and made my life so much easier doing that. Now, I guess I should also point out the fact that if you've ever used like the auto-generated captions on YouTube, which is where like the auto transcript comes from, they aren't exactly always perfect. They are known for slipping up here and there. So there's a chance you might miss something by doing this, but at the end of the day, I mean, it's going to save you a ton of hours still. So overall, I think it was pretty well worth it. But with that, let's go ahead and move into this C++ drama. So the proposal is for I guess they're calling it safe C++ or safe C++ extensions, essentially. So essentially the goal here is to introduce memory safety into C++ and try to address the memory safety vulnerabilities that exist currently in C++, because it's kind of a key issue that has been around C++, essentially since its inception, but also C as well. But if you've listened to the podcast for a while, or you know anything about C++, that shouldn't be breaking news to anyone. So, of course, the motivation behind all this is the tech industry, both the public and private sectors, have been pushing for developers to adopt memory-safe languages like Rust, like Java, like Swift, like Python, although I think specifically, like we talked about whenever that was when the White House put out that whatever it was that's essentially a press release or whatever, encouraging industry to move to memory safe languages. And then, of course, DARPA with their whole tractor thing, translating C to Rust or whatever that backronym was. But essentially, transitioning the industry to memory safe languages to remove all of the memory safety vulnerabilities that happen, because as we've referenced the statistic a few times on the podcast already, the whole 70% of vulnerabilities that happen are because of memory safety issues. If you can cut out 70% of the vulnerabilities in software, that's a pretty big deal. So organizations like the NSA, Microsoft, and DARPA have essentially been urging for the use of memory safe programming languages due to these security risks posed by using C and C++. But of course, the challenge here arises that although, C++ in theory can be written in a memory safe manner, when we talked about, memory safe programming languages, I believe it was during that episode where we talked about, the White House statement on it. We talked about that C++ can be memory safe, assuming you write it correctly. So really the issue here is it's a skill issue. But joking aside, as we kind of touched on, yes, technically you could argue it's a skill issue, but seeing that it's been a so-called skill issue for how long has C++ been around now? Since like the 80s, 90s, something like that. It's been around a while, so you would think this kind of skill issue, if you will, would have kind of been resolved, but yet it always seems to come back up. So while yes, technically you can write C++ safely, critics argue that it's of course not practical in real-world scenarios because, various levels of skill, if you will, skill issue. Now, as far as the proposed leaders for this, so this is kind of a joint effort, if you will. So the Sean Baxter, which is the Circle compiler creator, and Christian Mazakis, I'm probably butchering his last name there, from the C++ Alliance, are essentially spearheading this effort to create this C++, or the Safe C++ initiative, essentially incorporating memory features like Rust's borrow checker and initialization analysis, as also using the safe and unsafe, kind of like an unsafe or safe and unsafe kind of keyword representation. So I've seen it described online that they're essentially trying to make like Rust on top of C++ or C++ on top of Rust or something like that. But I will say, looking at the proposal, which I'll have linked in the show notes below, some of the code for Safe C++ does look quite funky. So if you thought some of like the modern C++ implementations for some of the new features looked weird, some of this type safety stuff for Safe C++ looks super weird. But anyway, with that said, of course, I think the big inspiration for this was Rust, specifically because Rust I'm not going to say it's already solved this issue. If you could kind of say it did already solve this issue, because it's a memory safe language. 2, it's used for systems programming, and 3, it has this safe and unsafe feature that allows you to interact directly with memory and memory addresses using the unsafe keyword. You can interact with existing C and C+ libraries again through that unsafe keyword. So I think a lot of the inspiration for the Safe C++ kind of came from that. And of course, Rust also offers, strong memory safety guarantees, but kind of the reason why people still tend to go for C++ is because Rust lacks some of the features like C++, so things like, function overloading and templates, things like that. but also because of those kind of things that Rust doesn't have, it makes migrating to C++ from C++ to Rust a lot more challenging. It's a lot easier to do in C because you don't necessarily have those function overloads and templates, which is, I guess, why DARPA used that for their whole tractor thing, right? Translating C to Rust. But translating C++ code to Rust is definitely not nearly as, I guess, trivial, even if you can call, translating from one language to another trivial, which, as someone that has translated code from one language to another, I've done it on a few different occasions. It's not necessarily difficult, assuming you're well versed in both languages, but it's tedious. It is very tedious. And as we'll kind of get into, and we've already touched on it, in previous episodes, but we'll get into it a little bit more, kind of some of the issues with translating an entire code base from one language to another, but we'll get into that in a little bit here. But first I wanted to touch on some of the key features that Safe C++ is planning to implement. So Safe C++ aims to offer memory safety while also allowing existing code to work, and kind of doing this through a incremental opt-in approach rather than kind of forcing everyone to do it. So in theory, this would make it easier and less costly than a complete language rewrite, since, kind of as we've touched on before, rewriting an entire code base is not very practical for a few reasons. Now, of course, in previous episodes, we kind of went into this in more detail, but just to kind of hit the highlights, some of the big reasons why it's not practical is, one, is time, which I think should be fairly obvious, because if you're, spending developer hours on translating your code base from one language to another, that is developer hours that are not being spent on either implementing new features, fixing existing bugs, or otherwise maintaining the code base. So it's a big decision to say that you want to translate from one language to another. Kind of the other issue, kind of in the same vein as time, is even if you are okay sparing those developer resources to translate the code base, theoretically, at least I would hope, you're still maintaining the existing code base and continuing to build on it and add features. So while you build on and add those features, you also have to translate those over to the new language, so you're basically adding more work for yourself. But the other issue, kind of the other big issue, is this idea of pedigree. And even if you build the most robust test suite imaginable, your new version that you wrote in this other language has never been tested before. And your old version, whether it was in C or C++, while it might be prone to potentially have memory safety vulnerabilities, it's been tested and running in production for potentially years or even decades at this point. So it's tested, it's not going to break, it's not going to crumble under the pressure, it's robust enough to hold up to all the traffic that it receives on a daily basis. If you completely rewrite the code base, while it might pass all the test cases just like your C or C++ version does, you haven't actually tested it against a production environment where it has to, face the barrage of either floods of traffic, potential attackers trying to, do nefarious things. It hasn't been tested in a robust manner like that you would expect in a production environment, and thus you can't necessarily rely on it. So this is now, of course, the obvious mitigation plan to this is a staggered rollout. Something that CrowdStrike could probably take a lesson from. But essentially the idea of a staggered rollout is you don't mass deploy your new feature set. Like if you look at any of the big software vendors. YouTube's a prime candidate for this, but even like social media companies, or just other software vendors in general, what they'll do is they'll essentially kind of A/B test and guinea pig their users. So essentially what they'll do is they'll create a new feature that they want to test to see, what users think or if it actually works. So what they'll do is they'll push it to a select, portion of their user base, whether that's, 1%, 5%, maybe 0.5%. Of course, it depends on how big the overall user base is to how many people they want to test it with. But essentially, they test it on a small scale, kind of gain some feedback, see what people are saying about it. Does it actually work? Things like that. And then over time, assuming the feedback is good, they'll start, pushing the feature out to more and more users until their entire user base is on this new version. So that's essentially what, this idea of a staggered rollout is. So if you are going to, completely rewrite your code base from one language to another, this is kind of the approach you would want to take. You wouldn't want to do the CrowdStrike approach, is where you just go full send, and then if you happen to, have a bug in the code that causes a blue screen, oh well. We'll just have the users manually go in on their own time and, remove the bad file, right? Now, of course, I'm kidding here and liking to make fun of that situation. But in theory, that is how you should be operating. If you do plan to rewrite your entire code base, you definitely should be doing a staggered rollout rather than just going full send on it, because, like I said, you don't have the pedigree. You don't know if it's actually going to work in production and hold up to, the mass amounts of traffic, that kind of a thing. So getting into a little more of the specifics of the features, kind of as I touched on, there's safe and unsafe specifiers, kind of similar to Rust. The proposal has bounds checking for most of the built-in types. So of course that was one of the big issues, with C and C++, is you could have an array of essentially 10 elements, but C++ would be more than happy to let you go on to the 12th, 15th, 20th element, way beyond the bounds of the array and into arbitrary memory. But of course, memory-safe programming languages don't allow you to do that. So bounds checking being implemented is definitely a good memory safety feature to have. And also during these kind of safe contexts, if you will, you are no longer allowed to do things like pointer arithmetic, pointer dereferencing, pointer comparisons, inline assembly, and using uninitialized variables. So all of those points I just listed are very common culprits for a whole sort of memory-related issues. Things like dereferencing a null pointer, or using a variable after it's already been freed, or trying to write to a variable after it's been freed. So these are some of the kind of the big issues that you'll run into, with C++ and C programs, because of course, even with that, even you could, of course, not use the safe context. And so if you still want to play with your foot guns, you absolutely can. And I would assume that by default it uses an unsafe context, is at least kind of my assumption, because one of the points of safe C++ is that legacy code is still going to work, and it's kind of an opt-in thing. So if you have, this safe context where you're not allowed to do things like pointer arithmetic or pointer dereferencing or comparisons, that's going to break a decent amount of C++ code out there, assuming you transitioned everything to be safe by default. So my assumption here is it's going to be, I guess, unsafe, if you will, unless you specifically specify that it's safe. So those are kind of some of the features anyway of this whole, safe C++ idea. So as far as the kind of the next steps, kind of what the future looks like, Sean Baxter, which I said was one of the kind of the collaborators on this effort, if you will, for the Safe C++. So he said, quote, "With Safe C++, existing code continues to work as always. Stakeholders have more control for incrementally opting into safety." So, this idea, with greater industry participation, is definitely going to be needed in order to expand Safe C++, obviously, in order to cover all the features of it. And if you've seen the number of features in C++, it has been growing fairly steadily since its inception. There's a ton of features in C++ nowadays, which is honestly, it's kind of gotten to the point where it's unruly. I don't know if you can really truly be a master of the C++ language like you can with a language like C, because the nice thing about C is it is to the decrement of it, the downside of C is the fact that it's so limited in what you can do with the built-in functionality, right? But the benefit to C is because it's so limited, it's not nearly as hard to essentially become a master of the language because it's a lot smaller in scope compared to something like C++. Because C++, they're always adding, new features and all this other stuff to it. So you really always have to be keeping up with the latest and also remembering what was previously within C++. So needless to say, it's kind of hard. There's a lot of features, so transitioning everything to Safe C++ is definitely not going to be a small effort. But because it's opt-in, it's also not going to be an overnight fix either, because industry is slow, especially when it comes to adopting new C++ versions. It's a very slow process for industries to adopt them because, let's be real, big-time enterprises don't want to be the guinea pigs for things. There's a reason why enterprises like to use, long-term support releases for Linux distributions, distributions like Red Hat Enterprise Linux, distributions that tend to lag behind, sometimes years in regards to features, because they want something that's been tested, that's been verified, validated, has that pedigree, if you will. It's, gone through it. It's been tested. It's been proven to work. They're not going to be a guinea pig because they don't want to break something that already works. Because the other thing you have to keep in mind, too, is when you select a C++ version for your code base, generally speaking, like probably 99% of the time, if you upgrade your C++ version, say from 2017 to, say, 2023, more often than not, that's not going to cause issues. But there's always those edge cases, right? There's always an edge case where, something's going to happen and it's not going to work in the new version. So whenever you're upgrading anything in your build chain, especially a C++ version, for instance, you're always going to have to rigorously test and thoroughly vet everything before you can deem it ready for production, which obviously takes time to do so. Now, Baxter went on to say, quote, the next step to comprehensively visit all C++'s features and specify memory-safe versions of them. This is a big effort, but given the importance of reducing C++ security vulnerabilities, it's an effort worth making. End quote. Now, of course, this is kind of what we were touching on. The C++ programming language is massive. There are tons of functions and tons of features, so creating memory-safe versions for all of them is definitely not going to be any small feat. It's going to take a while, and kind of like Baxter said, it's a big effort. Now, this is completely my own assumption here, but I would assume that because their solution is to add memory-safe versions to all existing features, I think it would be seriously impractical to essentially create brand new memory safe functions, if you will. So what I mean by that is rather than having std sort, their new memory safe version would be something like std sort underscore s or something like for safe, right? So that, in my opinion, would be seriously unpractical or impractical. Although the benefit to that is it would allow existing code not need to be, you wouldn't have to change any existing code, right? Because the old function still exists, you're just not electing to use the new one, and it's kind of that opt-in mentality. The problem with that is if you wanted to opt into these new features, it's not as simple as just updating your C++ version to the safe C++ one. You'd have to manually go through every single one of your functions that are from the standard template library and essentially specify the new memory safe version, which again is time consuming and, depending on how big your code base is, very impractical. So my assumption on how they're going to do this is kind of how they implement, I think, a lot of the features in C++, which is with the good old if-def solution. So we've talked about if-defs before on the podcast, but essentially what an if-def is a preprocessor macro that essentially tells the C compiler at compile time whether or not to include this portion of code. So if-defs are a great solution, and they're used pretty frequently, especially in cross-platform C++ and C applications, because not all operating systems play nicely together. Code written on one operating system in C or C++ doesn't always work on another operating system, and it sometimes even is worse than that. Sometimes C++ written will compile with one compiler but not with another one. So having these if-def checks is essentially how you can account for that, and basically define, hey, if I'm on this operating system, do this, otherwise do this. If I'm using the GCC compiler, use this code. If I'm using the Clang compiler, use this code. Things like that you can define with an if-def. So I would assume it's going to be a similar thing here, where they'll take, kind of as we touched on before, that std sort, which is the sort algorithm for the standard template library in C++. So essentially my assumption here is they'll take that sort function and essentially do an if-def check to check which version of the C++ compiler is being used, and if it's, this new one with safe C++, they'll use, of course, the safe C++ version. Otherwise, they'll just use what's already been there. That's at least my assumption of how they're going to go about implementing this, because that would fix a couple of things. One, it would not make them have to write essentially duplicate every single function. So you wouldn't need that std sort and std sort underscore s. You just have std sort. So it fixes that. But two, whenever industries or individual developers or enterprises or whatever decide to upgrade to this safe C++ version and opt in, if you will, they'll already get to take advantage of all those memory safety features because they're built into the functions that they're already calling. So that is kind of my assumption, at least, on how they're going to go about doing that, because kind of in my opinion, that's really the only way you can do it without, one, making a ton of extra work for the developers of C++, as well as those that are going to be using, this safe C++, because in my opinion, if you don't, do that kind of override with the native function, I don't think your adoption is going to be very high, because even if people are using that new version of C++ that is the safe C++ version, probably by habit, they're just going to call the functions they've always been calling rather than, some new named function that's the safe one. I mean, there's of course going to be some people that do that and will always opt for the new safe one, right? But some of us, just out of habit, when you've been writing in a programming language for a while, especially if you have like autocomplete on your text editor, you're going to see that first one like std sort and just hit enter rather than looking for the memory safe one. It's not necessarily, it's kind of a unconscious decision of just, that, yep, that's the one I want, and clicking it. So I think that's really the only option. I mean, it's not the only option, but I think that's the most sensible option, at least in my opinion. But I would be interested if you have differing opinions on that. You can shoot me an email at contact@darkassassinsinc.com, or if you're on YouTube, you can leave a comment down below. But as someone that enjoys writing in C++, I mean, I guess I would kind of have to if I'm writing a video game in it. I am definitely very interested to see where this goes and how it ends up going, and, what this new version of C++, this idea of safe C++, when it'll ship. Because kind of as we touched on, getting back to, what Sean Baxter said, it's a big effort. So I think this is going to take a while. They're already starting to, put out features for C++ 26 already. So I definitely don't think this is going to make that release. So it's probably at least, or at soonest, the one after that, if not one later. So I don't know. I think realistically, we're probably looking at maybe like, so if 26 is kind of already being planned, I don't know, maybe like C++ 29 or 33 or something like that. I honestly don't know. It's definitely going to be a while, but I am definitely interested to see, one, when it comes out, and two, how quickly compilers and operating systems will incorporate this new version, since sometimes it takes a while before compilers can incorporate, all the latest and greatest features. And sometimes, when they come out with a new version, like, I think it was, I forget if I was using Red Hat or what I was using, but I was specifically specifying, I think it was C++ 20. And I was specifying a feature that, according to the C++ documentation, was a feature in C++ 20, but when I tried to compile, it didn't work because the compiler hadn't implemented that feature yet for C++ 20. So just because, the compiler says it supports a certain C++ version, it doesn't always support every feature in the language. It's kind of a mess. So it will be interesting to see, one, what C++ version it gets incorporated in. Two, when compilers will actually incorporate all of the features of Safe C++ into the compiler. And three, when will operating systems actually ship that version of the compiler to their users? Because just because a compiler, includes the new feature set, the operating system still has to incorporate that compiler and ship it out to its users, right? Like, of course, the notable, mention here is, LTS and, more enterprise-themed versions of Linux tend to ship older compiler versions, so they don't always include the latest and greatest, features and standards of the language. So it's going to be interesting to see when, these operating systems actually ship those features. But on the topic of C++ with memory safety, this isn't the first time that C++ has tried to add features to fix its memory safety issues. It's kind of like it's trying to, what's the saying? Something like putting a Band-Aid on a bullet hole wound, or it's trying to like mop the floor when they haven't turned off, the faucet yet. And whatever the case is, they're essentially trying to, patch and fix issues, but they haven't solved the root cause of the issues, is essentially kind of what's going on, at least in their past attempts to fix their memory safety issues. So of course they have things like, the standard template libraries, things like vectors and maps and, all these features that kind of have built-in kind of memory management kind of functionality. Also the smart pointers, we talked about smart pointers not too long ago, that it's kind of like a garbage collection, if you will, in sorts. It's a really dumbed down version of it. But the kind of the point of the smart pointer is that it's contextually aware of if it's being referenced anymore, and once it isn't referenced anymore, when it goes out of scope, it'll automatically clean itself up and delete the memory associated with it. So assuming you're using like a built-in type, you don't have to worry about freeing memory. Of course, if you're using a type that you created, like you created your own class, if your class allocates memory, of course, you're still going to have to write a destructor for that in order to free the memory, but that will automatically get called when the pointer goes out of scope, so you don't have to worry about calling it explicitly. But even with all these features, there are still, of course, memory safety issues with C++. Now, granted, most of these features were like the idea of safe C++, which it was kind of an opt-in thing, right? Like you could still use smart pointers or when smart pointers got implemented, you didn't have to use smart pointers. You could still use raw pointers. And kind of the issue with, I think probably one of the big issues with C++ when it comes to memory safety is the fact that any valid C program is also a valid C++ program, and C is not memory safe. So theoretically, there's always going to be the instance of, a C program being compiled as C++ and it's inherently not memory safe because of that. So I don't think there's really any patchwork that you can do to C++ that will make it truly memory safe. There's always going to be issues where someone is using a legacy code base. They have it even once safe C++ comes out, right? Even if we assume that all of the the baked in C++ functions all become memory safe, assuming that occurs, and every program that is compiled with the safe C++ version gains access to all that memory safety, and assuming that is a memory safe C++, there's always going to be the instance of code that is essentially native C code being compiled in as C++ that's not memory safe. Or, of course, the unsafe. There's literally the unsafe, specifier, right, that you can use to do unsafe things. So I don't think there will really truly ever be a safe C++ because it's not a programming language like Java or Swift or Python that was made from the get-go to be memory safe. Because even a programming language like Rust has that unsafe keyword that allows you to do unsafe things, where a language like Java, for instance, doesn't give you that access, right? Now, of course, the use case for a programming language like Java versus a C++ is obviously different, because you're not going to be using, Java to write an operating system because you can't get that direct access to memory. But still, kind of going back to what Sean Baxter said, quote, comprehensively visit all of C++'s features and specify memory-safe versions of them. So if we take that at face value, that should fix all of the memory safety issues once and for all. But of course, that won't actually fix everything, since again, you could still use raw pointers or pointer arithmetic and all the other foot guns that C and C++ are known for. Because I'm pretty certain that if a legacy code base that uses C++, if it's not using smart pointers already and it's using, raw pointers in a legacy code base, I think the likelihood that they upgrade everything is probably pretty small. I think the likelihood is probably pretty low at this point. So there's, of course, still going to be ways that you can run into memory safety issues. But I mean, that just kind of comes with the territory of having physical access to memory and being able to manually specify memory address. I mean, that it's kind of comes with the territory type of a thing. Now, with all that said, I have spent the past couple minutes here bashing this safe C++ idea. But don't get it twisted, because while I might be kind of hating on it right now and it's not actually going to fix anything, I am very optimistic for it. And I think the positives definitely outweigh the negatives, because even if this safe C++ doesn't completely make every C++ program memory safe, I think it's going to fix the vast majority of the memory safety issues, assuming, of course, that people are actually, making use of the safe C++ version of C++. So whether that's comes out to end up being, I don't know, say C++ 29, for instance. Assuming people are using that version, I think it's going to solve a lot of these common C++ memory safety vulnerabilities. Specifically, like, the one we talked about was the bounds checking, right? Having that automatic bounds checking for built-in types, using kind of that idea of the borrow checker, checking for use of uninitialized variables, things like that, having the safe context. Now, of course, the safe context is kind of something that you're going to have to specify. It's not something that's going to be manually incorporated in legacy code bases. But even still, right, 70% of the vulnerabilities in software are memory vulnerability related, right? We've hit that statistic. We're probably at this point beating it like a dead horse. So, but even still, right, even with 70% of those vulnerabilities, even if you don't eliminate all of them, even if you can only eliminate, say, 50% of them or 30% of them, that's still a large portion of vulnerabilities that you're fixing by improving the memory safety of C++. Because like we mentioned, it's not practical to migrate some of these massive code bases like operating systems, for instance, to another programming language. Now, of course, over time, you can migrate new features of a project to a new language and kind of, patch them together in order for it to work, and you can write the new features in a different language. But rewriting the entire code base in a new language is not exactly the most practical thing to do. So by taking a language that already exists and improving on the memory safety of it, and even if it doesn't fix every single possible memory safety vulnerability, if it fixes the majority of them by literally just compiling with the new version of C++, that's obviously going to be a net win, even if it doesn't fix all of the memory safety vulnerabilities. So at the end of the day, I guess to summarize kind of my thoughts here, since I've been kind of rambling for a while, I'm very interested to see how it's going to turn out. I'm optimistic that it's going to overall be a net positive. But I think at the end of the day, I don't think it's going to solve every single memory safety vulnerability. But again, I think it is definitely a net positive, and I'm definitely interested to keep following this and kind of see when this gets released. And whenever it does get released, try to, get some hands-on with it. And be able to play around with it and kind of test some of these things, right? Like the bounds checking is kind of one of the big ones that I kind of want to test. So yeah, that is kind of the proposal for Safe C++, kind of some of my thoughts on it. So I'd be interested to hear what you think about this idea for Safe C++. Do you think this is going to solve all of C++'s memory vulnerabilities? Kind of what do you think of this proposal? Definitely let me know. You can shoot me an email at contact@darkassassinsinc.com, or if you're on YouTube, you can just leave a comment down below. So before we wrap up, let's get back to our trivia question for the week. So the trivia question for this week is, introduced in 1985, what line of Commodore personal computers has the name that means friend in English? So once again, introduced in 1985, what line of Commodore personal computer has a name that means friend in English? If you said Amiga, congratulations, you got this week's trivia question correct. And I think that's going to just about wrap it up. So if you enjoyed this episode, definitely leave it a rating and review and subscribe if you haven't done so already. And be sure to share this round to friends or family members, especially if you know any developers that use C++ and they haven't heard about Safe C++ yet. Might be a good introduction for them. And I guess one thing I also should mention, the articles that I use to reference for this Safe C++, the Ars Technica article and the proposal for Safe C++ itself, I will have linked down in the show notes. So if you do want to go into more depth than what we did on the podcast, you have those resources available to you. And if you have any questions about this episode, or if you have any topics or comments or ideas for future episodes, if you're on YouTube, you can leave a comment down below, or you can shoot me an email at contact@darkassassinsinc.com. Of course, the link for that is in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.